Hello, everyone. This is Dr. Zach. I know you're surprised to hear my voice, but it is time for us to begin reviewing for that AP exam. So for today, we're going to talk about all different types of differentiation. Let's begin. For today's lesson preview, you are reminded that you need to use various rules with some abstract problems. So when looking for g prime of -1, you want to use that chain rule. Find g prime of x first, and that would be 2. Keep the inside. Here's your f of x to the first power times f prime of x. Now, to make things easier for yourself, do the substitution. Don't try to do too much without using proper notation. Let the notation guide you to find the correct answers. So both of these problems are all about the notation. For our second question, h prime of x needs to be found first, and of course you're going to use your quotient rule. Take your time, don't get too flashy, make certain you are following through with the correct notation throughout the entire problem, even when you have multiple choice. Next, you'd want to substitute to find h prime at 1 and use that table of values in order to set up your answers. So for today's lesson, you're going to have reminders of some of the ideas that were presented throughout the course. Implicit differentiation is one of those things that sometimes jumps out of our mind. So we want to find dy dx. Find a derivative with respect to x. dx is 1. But then when you find the derivative of y cubed, you get your 3y squared dy dx. Now remember to recognize a product rule. So you have your first times the derivative of the second, which is dy dx, plus the second times that derivative of the first. Now since we're specifically told to find dy dx, you want to isolate the dy dx. If you were told to just find a value, you could do the substitution first and then figure out your dy dx. So depending on how the problem is set up is how you want to approach finishing up your problem. Make certain that if you're asked to find a second derivative, your derivative would have a dy dx involved in the problem, and that would need to be replaced. So for question B, find the equation of the line that's normal. Now remember, if it was just a tangent line, you would substitute in for dy dx. But because it's normal, you want to find the slope of the perpendicular line. We're going to substitute the x and the y in. You find that the slope of your tangent line, once you do all of your substitution, is going to equal 4 over 5. Now, of course, we want to find the perpendicular, so that's going to be -5 over 4. Writing the equation to the normal then gives you y minus 8/3 equals your slope, which is -5/4, times your x minus 4/3, and then you can move on to the next question. Now, of course, I want you to give question number 1 a try, and when you're finished, make certain that you're looking for your dy dx. I'll even tell you the final answer. Dy dx, when it's all said and done, should be 0. Please make certain that you can show the work to support this answer. Questions 2 and 3, I'd like you to try on your own. Turn the video off. Once you've completed them, then check your answers. So for number 2, after you found dy dx, you were asked to find the second derivative and write your answer only as a function of x and y. Notice your dy dx does have, the second derivative does have dy dx involved in the problem. Replace that dy dx with x squared over y and simplify. For question number 3, perhaps you should rewrite your function so that the derivative can be found using implicit differentiation. And then I went along and I found the substitution to determine dy dx. Your final answer had values of y in it, and that is not acceptable. So we want to rewrite the problem using our right triangle trig and end up with a problem with only x's. So you should be reminded that the derivatives of inverse trig functions are very important to have in your mind. Note that the sign inverse of x and arc sine are the same thing, but they have domain restrictions. So you think about your domain as you do each problem. All right, so let's look at example 2 together. For example 2, you notice we have a product rule. So we will have, for our product rule, first times the derivative of the second, and that includes a chain rule. So that's 1 over 3x square root of your 9x squared plus 1 multiplied by the derivative of 3x, which is 3, plus the second part of the problem, which is the secant inverse 3x multiplied by 1. Clean up your problem just a little bit, and you have 1 over your square root, 9x squared, plus 1, plus that secant inverse 3x. Okay, so it's very important to make certain you know your basic derivative rules when you take your AP exam. Of course, I want you to try questions 4 and 5 on your own, and then check your answer. Turn the video off now. These problems were pretty straightforward. Just make certain that you use your chain rule and the appropriate derivative throughout your problem set. Next, let's review derivatives of your transcendental functions. Once again, useful rules that you are expected to know for your AP exam. You should also have these log properties within your mind. The log properties are used to offer different answers within a multiple choice test. So for example 3, let's determine the relative extrema for this function. So how do we find your relative extrema? Don't forget, you must always justify your answer. We're going to look for where the derivative equals 0 or does not exist. Following through with the product rule, you get x squared times 3 e to the 3x plus e to the 3x times 2x. Do a little bit of factoring. We're left with x e to the 3x multiplied by 3x plus 2. So what do we know? We know we have critical numbers where an x is equal to 0 and when x is equal to negative 2/3. Now just to make certain that the grader of your AP exam knows what you're doing, make this little statement. Let y prime equal 0. Now that we have the critical numbers, we're going to make a sign chart to help understand where the derivative is positive or negative. And just as a reminder, College Board will not use your sign chart as part of your grading system. This is to help you understand what's happening in your function. So the sign chart is totally for you. All right, notice that I've drawn where we have relative extrema, and since that's what we're looking for, now we're going to make some statements. There is a relative max at x equals negative 2 over 3, comma 4 over 9 e to the negative 2, since y prime changes from positive to negative at x equals negative 2/3. We're going to make a similar statement. There is a relative min at x equals 0, and we know this is 0, comma 0, comma 0, since y prime changes from negative to positive at x equals 0. And this, of course, was your first derivative test. For questions 6 and 7, you are showing me that you remember your basic derivative rules. So turn off the video and give these a try. So after reminding yourself about the derivative of 4e to the 2x, you should eventually end up with the given answer. Question number 7, the natural log of tangent of x. You used your f prime of x is 1 over the argument multiplied by the derivative of the argument. Now this answer looks like a fine answer, but you have a tangent in the denominator. Tangent should never be in your denominator. It can be rewritten as a cotangent over 1, and then you can simplify the problem a little bit more. For question number 8, you should use algebra before you do anything else. During a multiple choice test, it will be expected that you will use your algebra skills in order to recognize the answer. For question number 9, sorry, this one's just annoying. You had to use your quotient rule. There wasn't a way to simplify the problem before you began. Now, I want to remind you of logarithmic differentiation. You're going to use the natural log to simplify your complex equations. Differentiate both sides, solve for dy dx, and replace the y value. So for example 4, you can see this is a nasty little problem. But if you were to take the log of both sides, let's write it as log y to simplify. That would be equal to the natural log of this complex function. But because we know our natural log rules, we're going to use algebra to rewrite the function before we differentiate. So the natural log of y is going to be equal to natural log of x plus 1/2 the natural log, the quantity x squared plus 1, minus, you're going to have 2/3 times the natural log of the quantity x plus 1. Now, from here, the derivative is a whole lot easier than what we were doing before. We will find a derivative of natural log of y, 1 over y, dy dx, using implicit differentiation, is 1 over the argument plus 1/2 times 1 over the argument multiplied by 2x for the chain rule, minus 2/3 times 1 over the argument. Now notice we still have a y in the problem. That is not permitted. We want to replace it. So dy dx is going to be keep your 1 over x, simplify along the way, x over x squared plus 2 minus your 2/3 times 1 over x plus 1. And when you multiply by that y and place it over here on the left side, you're going to then replace the y with the original function. And we will have 1 over x plus x over x squared plus 2 minus 2/3 times your 1 over x plus 1 multiplied by that original function, which is x root x squared plus 1 over the quantity x plus 1 to the 2/3. Now this is often used to find the derivatives of problems that look like y equals x raised to the x power. Notice if you use log rules on that, the exponent will drop down beautifully. You can also use it on basic functions, y equals 2 to the x, in case you forget your rules. All right, so I want you to give numbers 10 through 13 a try, stop the video, and then check your answers. All right, so for number 10, hopefully you rewrote the problem using logarithmic differentiation, and you can check your answer to make certain you come up with the same one I have. Number 11 is truly implicit differentiation. Take a look at your final answer. Make certain that you are in agreement. Please don't forget the derivative of a constant is 0. It's been a while. L'Hopital's rule. So back to a few limit problems. Now, remember please, L'Hopital rule only works if you have an indeterminate form. But what's an indeterminate form? That's when you try to substitute, you get infinity over infinity or 0 over 0. If you have one of those forms, you can take the derivative of the numerator and the derivative of the denominator and try to apply limits again. Now, just to be certain you're on the same track, you are never, ever allowed to write the infinity over infinity or 0 over 0. So if for some reason you have written it, you must cross it out so that it will not be part of your graded exam. Now for question 13, this one was the definition of the derivative. Okay, so AP is not going to tell you to use the definition of the derivative, but you need to be able to recognize it. The definition of the derivative comes in the form limit as h goes to 0. It could also be the limit as delta x goes to 0. So you need to have a good appreciation for the definition of your derivative. Now, once you recognize that you have a derivative, then what you would want to do is just differentiate rather than using limits to solve the problem. Okay, so I want to be very clear that we are practicing for that AP exam, and everything in today's lesson was relative to what AP calls Unit 2 and Unit 3 on your exam. We did not talk about, it looks like, 3 topics for Units 2 and 3, but we will have those in another lesson. For today's follow-up, you are going to practice more derivatives. Since derivatives cover quite a bit of that AP exam, please know your derivative rules. And I'll talk to you another day.